Hi everyone, my name is Shubh Sahara and today I am presenting my final project for network security. The topic is Zero Trust Architecture for securing IP-based AV networks. What that means, in plain terms, is how do we stop the wrong people from reaching cameras, projectors, and audio systems that are sitting on a regular network? Let's get into it. So here's the situation. In most classrooms and conference rooms, AV devices, cameras, projector, digital signal processors, they are all connected to the network just like your laptop is. And in a typical flat networks, that mean any device on the same network can reach them. There is no wall, no checkpoint, nothing stopping a curious or compromised user laptop from just talking to the projector or camera. It has no business touching. This isn't theoretical to me. I work in classroom support services here at U Toledo and I have an upcoming internship with Little Caesars. Both environments where AV systems are critical to daily operations. If someone disrupts a projector mid-class or get into the camera system, that's a real problem. So the question becomes, how do we fix this without buying expensive enterprise security gear? The answer starts with a concept called zero trust. The traditional network model says once you are inside the network, you are trusted. You can move around freely. That's the open door on the left. Zero trust flips that. It says being inside the network means nothing. You only get access to what you are explicitly allowed to reach based on your role. That's the badge on the right. Now, full enterprise zero trust platforms are expensive and complex, but the core idea, least privilege access, explicit policy, can be applied using tools that already exist in standard networking, VLANs, and access control list. No special hardware requirement. Easy, right? So, who exactly are we protecting against? The threat model here is an internal one. It's not a hacker breaking in from the internet. It's a compromised or curious user device that's already on the local network. Maybe someone plugged in a laptop and it got malware, or maybe there is a poke, they are just poking around. The goal is simple: block the device from every reaching the AV zone. And importantly, AV devices behave a lot like IoT devices. They are always on, they rarely get patched, and they expose web interfaces, so they need to be treated as protected infrastructure, not just a room equipment. So here's the design I built. Three separate zones, each in its own VLAN. VLAN 10 is the AV zone. The camera, projector, and the DSP lives here on 192.168.10 subnet. The VLAN 20 is the management zone, just the admin PC on 192.168.20 subnet. And VLAN 30 is the user zone, which has all the regular laptops and it lives on the 30 subnet. The key piece is the router in the middle. It uses a router on a stick configuration, meaning one physical connection carries all three VLAN using 8001Q tagging, and the router becomes the enforcement point between them. The switch organizes device into VLAN, but the router is what decides whether traffic is actually allowed to cross between zones. This is an important distinction that easy to miss. A lot of people think VLAN alone are the security fix, and they are not. VLAN separate the broadcast domain, but if your router is doing inner VLAN routing with no policy attached, traffic can still flow freely between zones. The ACL is what actually enforcing least privilege. VLAN creates the zones, ACL enforce the policy. We need both. So what's the actual policy? The management to AV, like managements are allowed because admins need to monitor and control devices. And AV to management is also allowed for replies and status update. The user is blocked to access AV. There is no legitimate reason a student laptop needs to talk to a projector, and the users to management are also blocked to prevent any lateral movement. The important design point here is that this is enforced at the router, not the switch. The switch just group devices. The router is where the rule lives. And to test all this, I built the prototype in Cisco Packet Tracer in four phases. The phase one was a flat baseline. Everyone on the network, no restriction, just to confirm the problem exists. Phase two, I created a VLAN on the switch. Phase three, I did router subnet interface with 802.1q encapsulation, so each VLAN has a gateway. And the phase four, the critical step, added the ACL. You can see it here. The ACL named block users has one deny rule. Any traffic from the subnet 30 heading to the subnet 10 is dropped. Then permitted any covers everything else. This gets applied inbound on the user facing subnet. That's the entire enforcement mechanism. Four lines of config. And that's actually one of the most important takeaway from the implementation side. The configuration is simple enough that any network admin can deploy it in an afternoon. It just required a change freeze, a vendor, and a consultant. The complexity is in the understanding why the design works, not in the commands themselves. That's why it's practical for a real environment. So, does it work? Three tests. Test 1. Flat network. User laptop ping the camera, projector, and DSP all three reply. That confirms the problem. The laptop has full reachability and has no restrictions. The test 2, which is the zero trust design. Same user laptop, same target. All three request timeout. The ACL is working. The user cannot reach the AV zone at all. Test 3. Admin PC, same target, same zero trust design. All three reply successfully. Legitimate admin access is completely preserved. That's the proof of concept. The policy blocked unauthorized traffic and kept authorized traffic flowing. And it came down to four lines of ACL config on a standard Cisco router. So what's next? I will be upfront about the limitation. This was built in a Cisco packet tracer, not a physical hardware, so some real world behavior won't be captured. And the testing was ping based. I verified reachability but didn't test application layer protocols or run port scans. For future work, the most valuable addition would be denied traffic logging so you can actually see who has been blocked. Service level testing, stronger admin restriction using micro-segmentation, and eventually validating the whole thing on real Cisco equipment. That would be fun. So to wrap up, the core finding is this. Flat AV networks create unnecessary exposure. Any user device can reach equipments it has no reason to control. A three-zone VLAN design with router enforced ACL removes that exposure while keeping legitimate admin access intact. What makes this valuable is the cost. No PAC platforms, no identity systems, no special hardware, just a managed switch or router, VLANs, and one ACL. That makes it realistic for universities, corporate meeting rooms, and anywhere AV infrastructure needs better protection. And stepping back, one mindset shift this project reinforcement is that AV devices need to be treated the same way we treat servers and workstation from a security perspective. They are not passive room furniture. They are networked endpoints. Once you see them the way, isolating them become obvious, no optional. Thanks for listening.